Yeah. Is it visible now?
Yes, sir, it's visible.
Yeah. Good evening, everyone, and thanks for inviting me for this talk. My topic is totally technical, and it is a new technique for controlling the location of hydraulic jump in a rectangular channel. Basically, this topic uh, is one of the core topics in civil engineering, to be more specific, hydraulic engineering. This is all about the safety of dams which are constructed all over the world. Uh, as the first speaker, Dr. Pandey, he was talking of the energy requirements and production. So let me tell you the scenario in India. The total power production in India is around 4.5 lakh megawatt, and about 40% of it is hydropower. And of course, we have some very good examples in the world. That is, Norway is having almost 99% of its power as hydropower. That is green and clean, cheap source of energy. But yes, now the things are moving towards renewable energy, and people are slowly realizing the importance of renewable energy. Uh, Now you can see this hydraulic jump is a kind of energy dissipator. Means whenever the dam is filled to its full capacity, the excess water which is coming into the dam is required to be diverted to the downstream river safely. And this is the reason why we are constructing stilling basins which are forming hydraulic jump, and the safe disposal of water is possible with the help of this hydraulic jump. But whenever some problems are occurring, when the design is not sufficient, uh, when the hydraulic jump is not clear, it may be submerged, it may be swept up. So in that case, it is causing the danger to the safety of dams. Now you can see this is the picture of one of the dams, that is Karnapali Dam in Bangladesh, where the half of spillway has been completely damaged and the operations have been stopped. This is one of another example wherein the stealing basin has been damaged due to non-clear hydraulic jump, and it has caused the damage and is also stopped the functions of the dam. Now see, this is the new design which we have proposed for the formation of clear hydraulic jump in the stealing basin. The in normal case, yeah, this is the mathematical model for which I will not go into the details, but let me throw some more light on the technical aspects. Yeah, first of all, the experiments have been carried out in the laboratory to test the design of the end weir which you have developed, which is normally the last part of the stilling basin. Yeah, this is the laboratory weir, and it has been tested in the tilting flume in fluid mechanics laboratory, and the results are found good. But the plain weir cannot be used on field on actual dams. So for that matter, we have to go to the 3D weir, which is constructed in concrete. You can see another example of the damages caused at the foot of spillway near the stilling basin due to submerged hydraulic jump. Yeah. Now you can see in figure A, the end weir is completely rectangular, the same top view of end weir. And in the figure E, you can see the end weir geometry which we have developed for the clear hydraulic jump. Yeah. Now, with the modern tools, of course, the physical model studies are not always economical, as it is very time consuming as well as resources consuming. So that's why we resort to the numerical model, that is CFD studies. Now here you can see we had used, now this study was carried out long back, maybe in the year 2010 or 13. So we had that time we had used Gambit and the CFD solver, that is Fluent. The You can see this is how the geometry is prepared in the software, and after the, yeah, now you can see some of the intrinsic details. We had used three-dimensional double precision model, then pressure-based Navier stove, volume of fluid, and SST K omega, that is shear stress transport K omega model. That turbulence model has been used, and the solution initiated with unsteady flow condition. And the boundary conditions are like At inlet, we had used velocity inlet. At outlet, pressure outlet. The bottom and vertical sides were considered as wall, and the top symmetry has been used. And to reduce the computational time, model is run with half symmetry. Now, these are the channel sections: influent, the velocity inlet, the actual wear section, 2D wear, which I had used, and the at the end of a flume or channel, that is pressure outlet. Now you can see in the figure B, the we had captured the vector diagram of hydraulic jump, which is formed in the numerical model. And at the top of the jump, you can find the reverse flow is there, and it is very important thing to be observed in the hydraulic jump, and that important feature we had captured in the numerical model. Now, the figure A shows the progressive formation of hydraulic jump, and in the uh, bottom of figure A, you can find that the complete jump has been formed, or clear jump has been formed at the foot of spillway. Yeah, there are some limitations of the model. After testing the 2D model, we had shifted to 3D model, and you can see the half symmetry of 3D wear, which is also called as broad-crested wear. And after testing the broad-crested wear, again we could form the clear hydraulic jump at the foot of spillway. The colors are showing the intensity of pressure in the water flow. And we had also uh, tested the 3D model in the physical study. In the left figure, you can see the actual channel or tail channel of dam and the damaged stealing basin. The same study has been carried out by one of the research institutes in India, and with the help of the research grant which we had received, we had carried out the physical model study with our end wear, and the results were quite optimistic. This research was funded by Board of College of University Developments, Pune, and yes, the results were really fantastic. And we had suggested the this kind of geometry for the government of India for to be applied or utilized on the dams. And this is the error analysis. It shows that the results are quite optimistic, and they are uh, showing the positive nature also. Yeah, and was the conclusion of the study. But yes, nowadays we have so many platforms or AI models which are available. At that time, maybe 15 years back, we used to have very limited resources. But nowadays, we are using different AI models. Like Google Studio is one of the model in which we had carried out the replica of similar study, and the things have become very much simple nowadays. So we must resort to different powerful AI models. But of course, the validation part is one of the important thing to be considered, because normally in hydraulics the validation is carried out with the help of physical models. But of course, the initial time which is required for testing different models, you can call it as trial and error process. So a lot of this time or resources can be saved with the help of the AI models. So this will be the use, and of course in the days to come, the people will go with more and more AI models, and the models are also themselves they are upgrading. And in days to come, we may reduce the efforts which are required in the physical model studies. So I think this is all from my side, but yes, I would like to add a few things about education. To me, education is a journey from information to knowledge, and from knowledge to wisdom. Now, as we all know, information is easily available, and it is readily accessible, rather it is available on our fingertip. You just google it out, and nowadays you can use any AI model, you will get enormous information. But whether the enormous information which we are getting on our screen, is it of direct use to us? The answer is no. We have to pick up the elements of knowledge from this huge information. And collection of knowledge, will it suffice? The answer is again no. From this huge knowledge, we have to pick up the elements of wisdom, which can be applied on the direct field. For the various applications, the knowledge implementation of knowledge is very important. And of course, the new generation is more and more techno savvy, and of course, rather than our generation, they will accept and learn the new things which are coming up in the market. But of course, ultimately, the humanity should be benefited at large. That is my opinion. If you are having any questions, you are free to ask. Thank you.
Thank you so much, sir, for sharing your extensive expertise in hydraulics and water resource engineering. Your presentation has enriched our understanding of innovative approaches in civil engineering research. We truly appreciate your valuable insights and contributions. Thank you, sir.
Well.